Okay, today we're looking at a merit style question, and the only difference between this question and the achieved question is that it uses some letters instead of numbers. So we've still got a point that we're starting with that we want our conics to go through, 3, 3, and so I'm going to just put that here. And then we've got another point we want our conic to go through that's p units away. So this distance here is going to be p to get to my other point. And that's sort of where it's different, because I don't know if p is 10 or 20 or anything. It's just a letter that represents something unknown. But more importantly, if I want to draw some conics, I need to know where my center is. And so that's going to be there. And so I have to think about, well, how do I get to my center from the origin? So I can come up with my h, k, and r values if I'm doing a circle. So the easiest one, I think, to start with in this case is our k value. So that's the vertical shift from the origin to where we want to be, and that's actually a discrete number, that's just 3. The horizontal shift's a little bit different. To get to here would be 3 units, and to get from there to the center would be half the distance of p, because if the whole distance from here to here is p, this would be p over 2, or half p. So the h value in its entirety will be 3 plus p over 2. And just notice I put that in brackets because I want to keep it all together. And this has also sort of answered what the radius is going to be. So the radius will also be here p over 2, because that's the distance from the center to the edge. And now once I've got that, I can start filling in my Cartesian and parametric equation. So my Cartesian equation will be x minus 3 plus p over 2. I've got some sort of double bracket here. Just notice I'm keeping it all together. Plus y minus 3 squared is equal to p over 2 squared. And just take note of those brackets. The parametric will be x is equal to p over 2 cosine of t plus 3 plus p over 2. And y will be equal to p over 2 sine of t plus 3. Now for our ellipse, just remember that we can keep our same h and k values for the ellipse. The r changes, it suddenly becomes a, and we've got this new value introduced, b. Now b can be whatever we want it to be. It could be a discrete number, like I could have it as 10, or I could have it as a letter as well, g, because I'm just coming up with an example of a conic that's going to pass through those 2 points. And I guess the important part is the horizontal distance, which we've kind of sussed out already. Just take note that g is not, or shouldn't be, p over 2. Okay, otherwise we've just got a circle again, and that's not sort of what we want. And so I can actually just change my existing equations a little bit to make them suit the ellipse. So instead of equal to p over 2 squared, it's going to be equal to 1, and then this will be over p over 2 squared, and this will be over g squared. And then for the parametric equations, the first equation is actually the same. The only difference here is in y, which becomes g sine of t plus 3. And then even better for us, keep it simple, is that for the hyperbola, most of this actually stays the same again, except instead of the plus here in our Cartesian, it's going to be a minus. And instead of cosine here and sine in these equations, we're going to have secant and tan. And then those are our 3 equations complete.